Let's look at a couple examples of converting angle measure between degrees and radians. To do that, we want to first remember that we have the relationship that 2 pi, 2 pi radians, so that is a full revolution, is also equal to 360 degrees. And if we divide both of those by 2, we get that pi radians is equal to 180 degrees. So we're going to use this relationship that pi radians is equal to 180 degrees to convert first from degrees to radians and then from radians into degrees. And we use the same ratio, the same values, the pi and the 180 degrees. We just use a different ratio each time. So let's see how this is going to work first with degrees. So we want to convert a negative 220 degrees into radians. And so to do that, we need to multiply a negative 220 degrees times a ratio. In order for us to cancel out the degrees, we need to have a degrees in the denominator. So doing that means that the degrees here cancel. So that means we need to have 180 degrees in the denominator of our ratio, and which, if we have the 180 degrees in the denominator, then the pi has to go into the numerator. So we're going to multiply a negative 220 degrees times pi radians over 180 degrees. When we do that, the degrees cancel. So we can go ahead and multiply this. So we multiply negative 220. That's negative 220 times pi. And then all of that is just over 180. And this fraction now, negative 220 pi divided by 180, is actually in radians. There's no degree units anymore. All that's left is for us to simplify. If we look at the numerator and the denominator, both of our numbers have a 0 in them, so we can, at the end, so we can divide both numbers by 10, and doing so gives us a negative 22 pi over 18, and 22 and 18 are both even numbers, and so we can divide the 22 and the 18 by a 2, and so that gives us a negative 11 pi over 9. And so negative 220 degrees is equivalent to a negative 11 pi over 9 radians. So let's flip that around and convert from radians into degrees. So if we have 25 pi over 12 radians, we want to convert that into degrees. And so we're going to follow a very similar process. We need to multiply our given angle times a ratio. And that ratio is going to use the pi and the 180 degrees. So since we already have an angle in radian measure, remember this 25 pi over 12 is in radians, we want to put radian measure in the denominator of our ratio. And so that means we're going to have to put pi in the denominator, because that's pi radians, which means the 180 has to go into the numerator. And when we do that, the radians cancel. And so our final unit of measurement is going to be this degree symbol. Okay, so it's the same thing that we did for converting degrees to radians. We just flipped the ratio. It's the same fraction, just it's reciprocal. The 180 degrees in the pi. So we can go ahead and multiply. Remember, when you multiply fractions, you multiply the top times the top, and then the denominator times the denominator. So we're going to have 25 pi times 180 degrees, and then all over 12 pi. And so all that's left is reducing. Both the numerator and the denominator have a pi, so we can cancel that out. And then we can also look at the 25, the 180, and then the 12. There's the factors of 25 are just really 5 and 5. 180, we could think of that as 6 times 30, and 12 is 6 times 2, right? So we could factor a 6 out of the numerator and out of the denominator. So we have 25 times the 30 that was left over after we reduced the 180 divided by the 2 that was left over after we reduced the 12. And again, we already canceled out the pi's, so they're gone. So I'm left with 25 times 30 divided by 2. And I know 2 goes into 30 15 times. So I'm just left with 25 times 15. And again, this is all in degrees. So what's 25 times 15? So 5 times 25 is 125. And 10 times 25 is 250. And so we're left with 375. So 25 pi over 12 radians is equivalent to 375 degrees.